Hello, so today I'll be showing you guys how to solve an IVP question using the Euler's method. So first up, let's understand how we derive the formula. In this graph, from below, y naught, y1, y2, yn, and then x-axis, x naught, x1, x2, and xn. Using the tangent line equation, which is y1 minus y naught is equals to mx1 x minus x naught. That's how we slowly get into the formula. So x1 minus x naught is also known as step size, or h, as it shows the amount of units that the coordinates travel from one point to another. And then m can also be expressed as fxy. So I manipulated the equation to make y1 the subject, and it shows y1 is equals to y naught plus h times fxy. Same for y2 is equals to y1 plus h times fxy. In terms of n, it can be expressed as yn is equals to yn minus 1 plus h times fxn minus 1 yn minus 1. Okay, let us move on to the Excel sheet. Okay, right here, I've already keyed in the equation, which is for x, I just increased it by step size, which is 0.1. And then for y is just the method I just showed you just now, which is y1 is equals to y naught plus h times fxy. And then this will be our x squared over y. So as I drag it down till column 12, where x is 1, then drag it down to the same column. And last but not least, all right, so as you can see, for y bracket 1, the results will be x is 1, y will be 1.257, or I can round it off as 1.26. X squared over y will be 0.795. Okay, so now let's move on to how we can solve the equation using Euler's method. So right here, I have reiterated and wrote down yn is equals to yn minus 1 plus h times f xn minus 1 yn minus 1. So right here, I just use a bigger step size, 0.2, so that I can reduce the amount of steps to repeat. How to know how the amount of steps? Just 1 minus 0 over 0.2, which I get 5. And that is the amount of steps I need to repeat to find the values for y bracket 1. y1, y is 1. y2 will be 1.008. y3 will be 1.032. y4 will be 1.080. And y5 is 1.150. Do take note that my y for the next for the subsequent like lines is actually changing in correlation to the previous y. Okay, so for our area analysis, using calculus, you can find that y is equals to square root x cubed over 3 plus 1, which we will get 1.155. So our y5, or our final y, which is y bracket 1, is 1.158, and the relative error, that the percentage for it will be 0.26%. So how do we reduce the approximation error? Is to use a smaller step size. There will never be a perfect perfect answer to reduce like approximation answer, the approximation error to 0, because this is all an estimate. So there will always be bound to have errors. Thank you.